So guys, it's Mr. Hanson at Mr. Hanson 414, and today we are going to start working with geometry using different types of angles, intersecting lines, parallel lines, perpendicular lines. We're getting started with all that. So in our books, it's lesson 4.1, angles formed by intersecting lines, and let's get started. Alright, so as you guys can see, this is where we're at. It's lesson 4.1, angles formed by intersecting lines. And our essential question, the big idea, the thing that we definitely want to make sure that we know after this video is, how can you find the measures of angles formed by intersecting lines? Straightforward. Highlight that. That's your question. If you can't answer that by the end of this video, you'd miss the point. So, when two lines intersect, this is a simple pair of scissors. We know not to run with scissors, kids. There are a number of angle pairs. So what are angle pairs? Well, what's a pair? So let's start using our brains. You can find the relationships between the measures. So using a straight edge, draw a pair of intersecting lines like that with scissors. So basically, and again, you guys know from past videos that this writing pad that I got does not really work with straight edges. So what they want you to do, and you can do it down here, is to go something like this, something like this. You know, make sure they're lines, so they go on and on. And then label the angles. So you got angle 1, angle 2, angle 3, angle 4. So you should draw something like that down there, nice and pretty to the best of your ability. Let's keep it moving. So use a protractor to find each measure. Now I know that not all of us do, but if you have access to the digital, if you have access to it, go for it. So if you look at it, angle 1, the measure of angle 1 is about to be 120 degrees. And I'm just going to fill this in, but you know, you can clearly see that 1 and 3 are a little bigger. Angle 2 is 60 degrees. If you measure angle 3, you'll get 120 degrees. And if you measure angle 4, you should get 60 degrees. Now, if you add those up, you should get 360 because it clearly makes a full circle. So it asks you to add up two measures. So 1 plus 2 is 180 degrees, 2 plus 3, 180 degrees, 3 plus 4, 180 degrees, 1 plus 4, 180 degrees. All the same. All the same. Let's figure out why and what that means. So we have been measuring, look at that, math without even knowing it. Vertical angles and linear pairs of angles when two lines dang, I'm gonna break my mic. When two lines intersect, the angles that are opposite are vertical angles. So when we had this example here, this angle and this angle are vertical angles because they are opposite. This angle and this angle are vertical angles because they're opposite. So make sure you know that. Make sure you know what a vertical angle is. Linear pair is a pair of adjacent. Adjacent means next to. So these two are linear pairs. 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 Adjacent angles whose non-common sides are opposite rays. So that is what makes an adjacent. And when two lines intersect, the angles that are on the same side form a linear pair. So clearly shows you what those are. If they're right next to each other, they're a linear pair. If they're opposite, vertical angle. So if we look at our diagram up here with the scissors, you know, you got vertical angles right here. Angles 1 and angle 3, or 2 and 4. Linear pairs. You got 1 and 4, 2 and 3, 1 and 2, 3 and 4. Any of those work. And there's probably some connections to this table. So we did number 1, make a conjecture about the measures of a pair of vertical angles. Well, if we look up here, 1 and 3 both measure 120 degrees. Right here, they look about the same, so we can say that they have the same measure and are congruent. Congruent. If you don't know what that is, quick Google it. First person to drop down a definition of congruent in the chat gets a asymptotic high five. Use the linear pair theorem. to tell you what you know about the measures of angles that form a linear pair. Angles in a linear pair are supplementary, and that's a vocab word. Supplementary, they supplement each other, which means they add up to, any guesses? Should look at your table. 180 degrees, which makes sense because they're right next to each other. They make a straight line, 180 degrees. Bam, bam. Nice job, guys. High fives all around. Supplementary angles are always adjacent angles. Opposite angles are always congruent. That's 2 takeaways. I'd write those down. So, proving the vertical angles theorem. Geometry loves their theorems, man. Let me tell you. If 2 angles are vertical angles, then the angles are congruent. We said that, but we got to make sure we got proof. And I need you guys to work on really speaking to the details, provide enough evidence to prove your points. So, we know that 1 and 3 are vertical angles. And we know that 4 and 2 are vertical angles. Now this little sign right here, and you put a little more swerve up on that thing, means they're congruent. So this means congruent. So we've talked about proofs, guys. You know, there's a lot of ways to get into proofs, and we're not going to spend a ton of time formalizing them. A proof is anything that can prove your point, provide a justification, provide evidence. So try not to get overwhelmed. If you talk to a lot of people that have taken geometry in the past, that's one of the things they usually don't like, is that they'll tell you that they didn't do the proofs. A proof could be anything. Just prove your point. So we got something called a flow proof. And again, boxes and arrows. I'm not really going to talk too much about that. But anyways, we want to prove that we're given 1 and 3 are vertical angles. So 1 and 3, we're saying that. But now we got to back it up. We got to provide claims. Don't be fake news. Don't be fake news. Something else to remember, guys. You know, how do we identify vertical angles? They are opposite angles formed by intersecting lines. That's probably something I would write down. So let's finish this out. So it says complete the final steps of a plan for a proof. So because angles 1 and 2 are a linear pair, which means they are supplementary and add up to 180 degrees because they're adjacent, and 2 and 3 are a linear pair, same things. These pair of angles are supplementary. This means that angle 1 plus angle 2 is 180 degrees, and 2 plus 3 is 180 degrees because that's the definition of supplementary. By the transitive property, we're saying that that equals that, because if this equals one thing and this equals one thing, both those things equal that one thing. So now what we could do, if you look at this, you see that there's a commonality, right? Measure 2 and measure 2 on both sides. So you can subtract that from both sides using the subtraction property of equality, and you can discover that the angle measure of angle 1 is equivalent to the angle measure of angle 3. Y'all didn't see how long it took me to make that M curve. You see there's a little dip in there. Got stuck. So what you can say is that the measure of angle 1 is therefore congruent. I gotta get a little more swerve on that thing. To angle 3. So this is this flow proof thing. I mean, it reminds me of this programming program that I used to use a lot for work called LabVIEW. If you take Project Lead the Way classes, there's another software that you're probably using there. Your boy tired a little bit today. Alright, so we know that this is true because it was given. We know that angles 1 and 2 are I'm just going to write supplementary. And we know that if you add them up, they are 180 degrees because it's the definition. And angle 2, measure 2, angle 2, and angle 3 are also a linear pair. We talked about that up here. Therefore, they are supplementary via the linear pair theorem, the THM. And you can add up angle 2, measure of angle 3 to get 180 degrees, which is the definition of supplementary angles. So you notice how things are repeating themselves. So take the information given to you and try to reuse it. And then the definition of congruence is going to state that, you know, based on what we did up there, we're just literally taking down that the transitive property of equality and then we use the SPE, the subtraction property equality, to get rid of the measure of angle 2, is the definition of congruence, which says that the angle 1 is congruent to angle 3. Whew! It's flowing. Using the other pairs of angles, angle 2 and angle 4, would prove that angle 2 is congruent to angle 4 also show that the vertical angles theorem is true. Well, let's take a look real quick. What do you think? Well, if they're opposite angles, then they would be congruent. So it would work, because it doesn't matter which pair of vertical angles you use. You have the top down and the side down. You can use similar statements, similar reasons. You got to make sure you're using the angles that make sense. Number 5, draw 2 intersecting lines. Sure, I can do that. Follow directions. Label your lines and tell which angles are congruent. So we got A, we got B, we got a D, and we got a C, and we got angle E right there. So if this is what we drew, that's it. That's an E. We could say that by the vertical angle theorem, the measure of AEC is equivalent. There's a nice little swervo. D, that's a D. EB, and you can say that the measure of angle AED is congruent to, so AEC, and DB, and then in this one we got AED. Why did I use that same color? We got AED and CEB are also congruent. And if you measured them, if you took the protractor out, in my example that I'm using, the measure is something like 45 degrees and 135 degrees, but that your results may vary, right? I think we're rolling. Take a quick pause. All right, so we want to continue. We want to proceed, and we're going to look at how we can use vertical angles. So now that you have an idea of what they are, I'm pretty sure you've seen them. They're used, and I'm not going to speak to the validity of some of these real world examples, because sometimes math books be just coming up with stuff. But I know that this example is true in some capacity, that you cross the braces to provide better support with woodworking, and I know very little, but if you do know, you know. So we do know right now. Let's look at what we know. This is, I think, so important for any math doing. What do you know and what are you trying to figure out? Well, we know that there are 4 angles present. We know that these are 2 lines, essentially, right? They're intersecting. We know that one angle measures 146 degrees. Okay. We also know that a circle is 360 degrees. So we could off top subtract 146, and we can see, if I can do some basic math, that there's 214 degrees left up in that thing, right? We know that. Okay. So let's find the other angle measures. So because the vertical angles are congruent, right? Because they're vertical angles, and we've proven this. This is a thing we can do. This, I'll mark it in pink, is going to be the exact same. So that's another 146. So we can take another 146 away from this. Let's see, 70 on top of that would take it too far, so it would be 68 degrees. There's 68 degrees left for angles 5 and angle 7. So 5 and 7 are also going to be vertical angles. Now, before I try filling out the book, because this is why I don't love this book, let's just be smart here. Let's use our brains. Take a look at this line, right? This angle measure is what? It's 180 degrees. So if that's 180, we know based on supplementary angles, because angle 5 and angle 6, or the 146 degree angle, are supplementary, they're adjacent, that they have to add up to equal 180. So you can say, what plus 146 makes 180? Well, that's 34 degrees. So angle 5 is 34 degrees. And because 5 and 7 are vertical angles, that's also 34 degrees. And we're done. So I think that's what they were going here. Yeah, they linear pair, supplementary, right? And they did exactly what we did. big brain energy, 34 degrees. I'll just fill this in so you got something to look at. And that's your vert angle. Boom. Question, if two of the lines intersect to form 4 angles and one of the angles is an 80-degree angle, how do you know there is another one? Well, you know that if there's 2 lines intersecting, that there's got to be a vertical angle. And those opposite pairs would be congruent. So if you know one measure, you know the other. So this is where what's actually kind of exciting is that for a lot of these, we're going to get into algebra. You need to be able to use your skills of solving equations and writing equations to help you find out your answers. And this is where there's a nice blend here. So hopefully you got some skills. So the measures of 2 vertical angles are 58 degrees and 3x plus 4. Find the value of x. So if you're unsure, you could always draw a picture. And this could be your 58, and then I'm not going to write it because I'm just going to put a little 1 there. Let's say that was 1. Those are your vertical angles. So you could set them equal and say 58 degrees is equal to 3x plus 4. That's just a 2-step, guys. You better be ahead of a 2-step. If you can't hit a 2-step, go watch my algebra videos. I got a ton of them. Subtract 4 on both sides using the subtraction property of equality. Train track that thing. We got 54 equals 3x. Divisible, yeah. 20 would be 60, take away 2 would be 18, so x equals 18. So what that tells you is that value for x is 18. That's not the angle measure, it's the x value. So if you plugged 18 in, you'd be able to figure out that that's 58 degrees. Again, you're applying the vertical angle theorem. Number 7, I'll just set it up for you. So the measure of 2 vertical angles are given by expression. So you don't know the numbers here, so all you got to do, same rules apply. If the vertical angles are equal, they're equivalent, so set them equal. And then solve. So you get x equals 10 if you did solve that. Now, if it wants to tell you the measure of the angle, you need to plug the angles in. Sorry, you need to plug the 10 in for x. So you can do 10 plus 3, which is 13 degrees. And 20 times 10 is 2 times 10 is 20. I always give the answer out. 2 times 10 is 20 minus 7 is also 13 degrees. So the measure of the angle is 13 degrees. Using that knowledge, you could say, well, if this vertical angle is 13 degrees and 13 degrees, that adds up to 26 degrees. That means these 2 vertical angles must add up to whatever's left. Or you can go the linear pair way and say, well, if one of the angles is 13 degrees, the other has to be a number to add up to 180, which would be 167 degrees. Be smart. Be smart. So now we got a new vocab word coming in the bank. Complementary. Be nice to your angles. Complementary angles add up sum of 90 degrees. Write that down. Supplementary, 180. So one makes a right angle, the other makes a straight line, 180 degrees. Don't get them confused. Complementary, supplementary, bam, bam. So we have a diagram here, and you're going to see how all this kind of blends together. So we know that this angle measure right here is 90 degrees. We know that. Yes? We also know that this angle measure right there, BFC, is 50 degrees. We don't know this one. We don't know this one. We don't know this one. So we have to take an inventory of what we know and then figure out what we don't. So let's read through what they say. Find the angle measures AFC. So I'm going to use some different colors to mark these. AFC, AFC, and AFB, AFB. So figure out what those measures are. That's our job. Well, we know that AFC and CFD are a linear pair, because if you look at this line, AFD, this line, comes all the way over, makes 180 degrees. So we know that. So we know that AFC plus CFD has to equal 180 degrees. Well, we know CFD, the measure, is 90 degrees. So if they have to be a linear pair, that tells you right away that AFC has to be 90 degrees as well. That was relatively simple. Okay? We know that. Now, if you look at the diagram, you also know then that this is a right angle. We can throw that in there. So now what we don't know is what I marked in this ugly mustard yellow is the AFB. Low-key, I kind of want to, if I had a sweater, that'd be fire right now. This is 50 degrees. So knowing that right angles, 90-degree angles, complementary, let me even get the verbiage right, AFB and BFC, use red for that, BFC, have to add up to 90 degrees. So that means that if this is 50, clearly this other one is 40 degrees. Complementary, supplementary. Know the difference between the two. So now you can continue. I'm going to erase just a little bit because it's getting a little crazy. So I highly recommend using different color pencils, highlighters, things when you're doing this because it can get a little messy. Find the measures of DFE. So DFE. And AFE. AFE. Okay. So figure out a game plan. What do you know already? What don't we know already? Well, we know that BFA and DFE are formed by... Wait, did I mark BFA wrong? Oh no, BFA is over here. BFA and DFE are two intersecting lines. So you see the lines, they intersect, right? Intersecting lines. So that's int lines, intersecting lines, interesting lines. And they're opposite, so these must be congruent. I marked them in dark blue now because they're vertical angles. They're opposite, right? Yeah. Vertical. So the angles gotta be congruent. We already know that AFB is 40 degrees. So we're not even doing no new math right now. We're just figuring out, we're being smart. So that's also gotta be 40 degrees because it follows the vertical pair. Now, BFA and AFE, so let me get a new color. So this angle to this angle forms a linear pair, which means that the angles are supplementary and they add up to 180 degrees. Degrees matter. Let's be a little more precise. A lot of times on the last quiz you guys forgot your parentheses and stuff. Don't be sloppy. So because AFE is going to be some part of 180 degrees, but we got to take away the BFA, which is 40 degrees. So 180 minus 40 is equal to 140. So therefore, this one right here in teal, 100, oh, that's ugly, 140 degrees. Right up in there. So we're using 90 degrees, 180 degrees, complementary, supplementary, vertical angles, linear pairs. Really, really the gist of it. Okay. The right angles, they both measure to be 90 degrees. So all right angles are congruent. Duh. That's pretty straightforward. Do I need to explain anything here? Got angle measures, complementary, supplementary. I'm going to let y'all mess with this. It's really just figuring out what's equal to what and then solving. Let's go down a little bit. So proving a theorem is different than solving a problem. Well, a theorem is just like a general, it's a statement. It's something that you can use in multiple cases. It helps you justify and prove your reasoning to do what you do, to solve. Whereas problems are like, this is a specific case, a specific situation. That's really the difference. The proof of the vertical angles theorem follows a plan. So how are plan for proof and the proof itself the same and different? Well, a plan is less formal. I'm cool with plans. Just write it out. You're making logical steps. You're writing out everything that you have, and then the formal proof just kind of adds a little more to it, a little more detail. How many, here's just a random question, how many vertical angles are formed, vertical angle pairs are formed where three tree lines intersect at a point? So if you intersected three lines, so draw that, what do you think? Let me know. Draw two intersecting lines, label all the points on. I'm going to let y'all do that. Just figure out which ones are congruent, which ones are complementary or supplementary. And then question, central question check-in. So remember, what did we set out to do today? You should have written that down very first thing. If you know that the measure of one angle in a linear pair is 75 degrees, how can you find the measure of the other angle? Well, if it's a linear pair, that means they're supplementary. It adds up to 180 degrees, so you subtract with the angle measure that you have. So let's go back and check in with our handy-dandy essential question. How can you find the measures of angles formed by intersecting lines? That was the point of today, and you know, there's many ways to answer it, but basically you identify angles with known angle measures. And if you don't have them, but they're drawn to scale, you can always measure them with a protractor, although that's not really our focus right now. Look for pairs of vertical angles where they're congruent and opposite, or linear pairs of angles that, you know, fall on the same line. Find complementary angles if you have any, add up to 90 degrees, and supplementary, which you probably will have, they're adjacent angle pairs, linear pairs, 180 degrees. So use those relationships to figure out what you know and what you don't. So let's take a look at what I want you to do for practice. All this is good so far. You know, anything that can reinforce this into a real world situation, again, take some of these with a grain of salt. I don't know how real accurate they are, but they try. So do some of these. I would do these. Don't get hung up on, you know, little stuff, but try your best. Definitely get any of these that have you set up equations and solve them. Make sure you get your practice. Plan for proof to, you know, practice sketching out what a proof would look like without being super formal. 2-column proof. If you want to go for this, go for it. You'll probably see it somewhere. Probability. If you want to try that, go ahead. You'll see a lot of that in stats whenever you take that. These are where you really make your money if you're trying to develop that level 3, level 4 advanced, proficient / advanced stage. You got to be able to think. You can't just do math. Like if you're just doing math, you're not offering a ton of value more than a calculator. So you got to be able to throw that human element, understand the problems. So these are all types of problems that would do that. So that's what I got for you guys. Lesson 4.1. We're going to work with this for a while. We're going to do a whole lot of cool Desmond activities. I'm going to try to get some videos of those so I can upload them so you guys can check those out. And I know I owe you all a video for transformations, but we just ain't going to talk about that right now. So that's what I got, guys. Mr. Hansen, if you haven't subscribed yet, hit the subscribe button.